Alright, so this video is about problem solving with proportions. First of all, I'm going to give you two known facts about proportions. One known fact is, if A over B equals to C over D, then B and C can interchange. I could then rewrite this as A over C equals to B over D. So I can switch places with these two numbers here that are in your extremes. So, actually these are the means, the two ones in the middle. So we can switch those two numbers that exist in your means. Alright, another fact is this. Alright, the other fact is, if A over B equals C over D, so the same ratio as previously, then I can rewrite each of these ratios as A plus B over B. So whatever number was there, I can add it to the numerator. And over here, I can rewrite it as C plus D over D. It has to be the same numbers there on top and bottom though. Like I can't take this B and put it over there and call A plus B equals C plus B, but I can take its portion of it, so the bottom part. So that's true. That's another true fact about proportions. You can add this denominator up to the numerator, add its denominator up to the numerator, and still have the same proportion. Alright, so there's two facts about proportions. It's true, nice to know, and really useful in the lesson we're talking about today. Alright, I'll get any of that you didn't already know as a note, and I'll copy that down. I'll pause the video because I'm about to erase all this stuff. So I'll pause it and copy all this as a note. Alright, so a new fact, or same fact we just talked about last, is with numbers now. If x over 8 equals w over 12, then I could rewrite this as x over w equals 8 over 12. That's a true statement considering the fact we know about proportions. And another one like it is, if b over 5 equals k over 6, then I can say b plus 5 over 5 is equal to k plus 6 over 6. And that still be true. It will still be the same proportion and they're still equal to each other. Alright, so anyway, those are good things to know. I'm about to clear the screen again, so if any of that was new or you feel like it's worth writing down, I would. If you feel like you got it, you don't need to write it down, that's cool. We're going to move forward. Alright, so here's an example. Here's a triangle here, ABC, and a small triangle ABD. Alright, it says if AB over BD equals to AC over CE, find the value of X. So you first got to figure out what they're referring to. Here they said AB over BD. So this is AB, this is BD. So this side over this one. So they said 10 over 15. Alright, make that look better. Alright, so 10 over 15 equals to AC over CE. So AC is going to be this part. Alright. So AC is this whole thing here. So that's X plus 10. Because that piece is X, that piece is 10, together is X plus 10. And that's going to be AB over CE. So here's CE. So that's 30. So given that proportion, solve it for X. So that's just a cross multiplication question that we've been doing for a while now. So I'm going to multiply 10 times 30. So it should be 30 times 10, after I multiply here, equals to 15 times X plus 10. Alright, so this is 300 equals to 15x plus 150. You probably subtract 150. You'd be left with 150 equals 15x. And from there, I would divide by 15. So x is 10. All right, our goal was to find x, so we just did it. X equals to 10. All right, that's how we can use proportions to solve problems in triangles. All right, give you one more problem. All right, I actually said one problem. I actually have two problems. And this is the first of the last two. All right, so the first problem is this one. It says a scale model of the Statue of Liberty is 105 inches high and 9 inches wide. The real statue is 305 feet high. How wide is the real statue? All right, it's really useful. They say it's a scale model, meaning that the actual model is to scale, as in the size of proportional. So by saying it's a scale model, that means the measurements are proportional. All right, so I hate to have to write on the Statue of Liberty, but there we go. So it means the measurements are proportional. So if that's true, since they went height first, the next thing they gave was width. All right, and the height of the scale is 100.5 inches, and the width is 9 inches. All right, so the real statue, they said it was 305 feet high. So you have to ask yourself, should I put it on the top blank or should I put it on the bottom blank or beneath the division symbol? So if that's true, it says height here and width is on the bottom. So since I'm looking for width, I know that one's unknown, and my height is what I do know. So I'm going to put the 305 on top. And my width, I don't know, so I'm going to call it X. It doesn't really matter that this is in inches and that's in inches, and this is in feet and that's in feet. It's going to work out perfectly fine because both fractions are in the same unit of measure, and our scale is going to be fine. So we cross multiply, we solve this. So right now, if you think you got it, I'll pause the video and I'll solve it for X to see if you come up with the same thing I come up with. All right, so what I would do is multiply here. So it gives you X times 100.5 equals to the product of these, 305 times 9. So I'm going to plug that in the calculator. My calculator says the product of those two is 2745. All right, so if I want to solve this, I divide by 100.5. So X is going to be 2745 divided by 100.5. So X equals 27.3 feet. And that sounds pretty reasonable. All right, so if you're looking at this 100 and that 9 is about 10%, about 9% of 100.5. So it's about, I'm going to go around that, it's about 10% of 100.5. So 305, 30 would be about 10% of that, and that's pretty close to 30. So slightly less than 30. And it should be because 9 is slightly less than 10%. So that sounds about right to me. So about 27 feet wide is it. So I'm going to say, so the answer to the question is, it says how wide is it? I'm going to answer the question as a sentence. So I'm going to say the statue is 27.3 feet wide. And that's my answer to that question. All right. I think you got it. If you need that as a note, I'll pause the video and I'll copy it. If you already have it, I got one last note to give, and this is it. All right. So this is about the geometric mean. And this says to find the geometric mean between two positive numbers, take the square root of their product. Product means to multiply them. So if I gave you an example, for example, it says find the geometric mean between the numbers 8 and 5. So I'm gonna call it GM. the geometric mean. I'll write the word out. Geometric mean equals the square root of 8 times 5. So it equals the square root of 40. Or about, I'll just plug that in the calculator. I got about 6.32. So the geometric mean is about 6.32. What is the geometric mean? Well, it's a special type of mean that we can find exists between two numbers. Where does it come from? It comes from the fact that if I have two numbers 8 and 5, I can make a proportion. 8 over x equals x over 5. Alright, and that's going to be the mean between those two numbers, make those two proportions true. So the geometric mean is the two numbers that would make this ratio equal to that ratio, or true proportion. So if you solve this, if you try to figure out what that number was, you get a product of these two, x times x. Well, I need some space. I'll just use that proportion. 8 over x equals x over 5. And I'll multiply these two. So x times x equals the product of those two. So 8 times 5. So x squared equals a 40. And you know, if you want to solve that, you square root the left side, you square root the right side. So x would be the square root of 40. You could call that a decimal. That's roughly, as we found earlier, 6.32. Or you can write it as a perfect square. Square root of 40 is 4 times 10. So that's 2 root 10. So you call it 2 root 10. You can call it 6.32. But that's the number that makes this ratio equal to that ratio once I replace it there. So that's what geometric mean is. That's why we go about finding it and so forth. It's really useful in triangles. It can be useful in different types of special theorems of triangles and proving stuff. So anyway, it's a nice fact to know. Anyway, that's all I have. Good luck.